All right, we're just going to talk about triangle congruence here. Excuse me. Um, so there's 5 different rules here. 4 of them deal with any triangle, and 1 of them only deals with right triangles. So I'm going to kind of go through these real quick, give you a couple of examples, and we'll move on from there. So, first rule, up in the upper left-hand corner, is SSS, which stands for side, side, side. So this side is congruent to that side. This side is congruent to this side. And this side is congruent to that side. And you can always tell because of the markings. And so each side is congruent to the same side on the other triangle, the corresponding side. And so that proves that they are congruent. Even though we don't know anything about the angles, if we know that all the sides are congruent to each other, we know that they are congruent. Okay, moving on to the next one. Top right-hand corner is SAS. That's side angle side. Now, the biggest thing you have to understand here is that when we look at SAS, the angle is in between the sides. So the A is in between the S's. Well, that's exactly what we must have on the triangles also. Here we have a side and another side, and the angle is in between them. Same thing over on the other triangle. Congruent to the corresponding side over there. This is congruent to the corresponding side over there. And the angle that's in between them is congruent. That's why that one works. It is very, very important on this one and the next one that you understand that in this case, the angle must be in between the sides. On the next one, down here at angle side angle, the side must be in between the congruent angles. So here we've got an angle, and here we've got an angle. So this angle is congruent to this one, and this angle is congruent to this angle, and the side that is in between those angles must be the one that is congruent. Right there. If we end up with that situation, again, we have congruent triangles. All right. And then this one is where we have angle, angle, side. So again, we have 2 angles that are congruent to each other, but this time the side is outside of the 2 angles. So we've got an angle and an angle, and they're congruent to these angles over here, and this time the side is not in between them. And that makes angle, angle, side. The last one is only good for right triangles. And even though it says RHS down here, makes it sound like a high school, normally this is just written as HL, hypotenuse leg. And so on any right triangle, if the hypotenuse is congruent to the other hypotenuse and one of the legs is congruent to the other leg, it makes these things congruent to each other. And if you think about it, it's kind of an automatic thing here because it's kind of like the angle-angle similarity. If we have 2 angles that are congruent to the other 2 angles, the third one has to be. Well, in this case, the same thing applies. The third side has to be congruent because of the Pythagorean theorem. So if we have a hypotenuse and a leg that are congruent to another hypotenuse and leg, the other leg has to be congruent. Now, they actually wrote this one in the nice way. They wrote it as SSA. This one does not work. Not work. And they kind of show the little picture here to show why it doesn't work. But Again, some people actually write it as ASS and just think, okay, that's a bad word in class. We don't say that. Well, it's a bad word in math too because it does not work. So, the reason why it does not work is because we can have a side here that's congruent to this side here. We can have another side that's 60 and another side that's 6. And so those two sides are congruent. And we can have an angle over here that's congruent to this angle. But we can still have a situation where we can have two different triangles. We can have one triangle where the side goes out to there, and another triangle where the side goes out to here. And so it can make that triangle, and it can make that triangle with a 6, 11, and a 30. So it can make two different triangles. That way we cannot say that these are going to be congruent. Now, a couple of examples that you might end up seeing with these are things like something like this, where we say, oh, this side is congruent to this side, and this side is congruent to this side. Prove why these are congruent. And you need to be able to pull some of your other information in that says things like vertical angles are congruent, and that proves that those are congruent. So then we have side, a side here and a side here, a side here and a side here, and the angle in between those sides. So SAS. Same kind of thing applies for if we have something like this. We can say something like, oh, this side is congruent to this side. This piece is congruent to this piece. Why are these congruent? Well, this middle one is common for both triangles. So this is the same side. It's this middle piece right here is congruent to itself. So we can just say, oh, that's congruent to itself. So this would be an example of SSS. And actually, I can come up with examples for every single one of them in these formats. So that's one of the things you need to be looking for is things like vertical angles or shared sides or shared angle or something like that. Okay, so that's it for tonight. We will see you in class.